Hi, this is Jamina Grace Talewik, and this is a video regarding the need for concurrency within the framework of an operating system. So when several processes run simultaneously, then concurrency exists. So here are practical examples in operating system we're very familiar of. Loading multiple documents simultaneously in the tabs of a browser while you can still open new applications and perform more actions. Or running computations in the background while working with interactive applications in the foreground. Still, a lot of single processing units employ mechanism to have concurrency. That is why we can distinguish concurrency in two forms. One, true concurrency, which happens in multiprocessor system where several different processes are executing at the same time. Or two, simulated concurrency in single processor system made to give the impression of executing several programs at once by switching between them so fast in quick intervals or when external input is required for processing. So this diagram illustrates concurrency as it happens in single processor system. So at t equals 0, task 1 is started, and then at 10% completion, it needs data from the disk. So task 1 would stop for a moment, and because task 2 will be started to be processed, and then at 45% completion, data from the disk is received, and so task 1 will continue again. And then at this time, the set interval for task 1 to run is finished, so task 2 will be processed back. And then at 80% completion for task 2, task 1 will continue again because the interval for task 2 to run has been reached. Then task 1 will be finished, and then task 2 will be processed again. And at 90% completion, the interval has been reached for task 2, so task 3 will start. And at 50% completion, task 2 will continue. And then it will be finished, and then continue back to task 3, then finished. So this, from task 1 being started until task 3 being finished, this is actually done in very fast. That it appears that task 1, 2, and 3 are being processed at the same time. So concurrency, therefore, makes operating systems more usable, efficient, and responsive. So efficient in a way that it avoids wasting processor time, because the scheduler can switch to executing a thread that isn't waiting to be provided data, thus improving processor utilization. And also to improve responsiveness, because a system accessed by multiple users can be more responsive through concurrency because it does not have to wait for user or IO input to serve other users.